Hello and welcome back to my series of videos looking at and supporting the science of evolution. However, if this is your first time visiting my channel, I will simply say hello. My name is Tony B and I am a multi-instrumentalist, singer-songwriter with a passion for science and the correct education of science. I hope you might find time to visit some of my other videos on this subject. I am covering everything from the evolution of the modern dog to our relationship with archaic humans and the evidence for deep time via sedimentary and igneous rocks. This video has a focus on the subject of redshift, which supports the Big Bang Theory, deep time and, consequently, the science of evolution. It is my intention to add my voice to the debate concerning evolution v creationism and to challenge the narrative and scientific denial promoted by various creationists on YouTube, some of whom are illustrated in this still. However, today is the subject of redshift. Kent Hovind is one such creationist who attempts to challenge redshift. Please note his dishonest interpretation of this scientific observation of an expanding universe in this next clip.
Misunderstanding the physics. If the light, let's say the star started 6,000 light years away from us, and the light began moving toward us, and then God stretches the universe, and the light is now 13.8 billion light years away, say. And now the light, which started 6,000 light years away from us, is reaching us. Yeah?
I didn't say it started 6,000 light years away.
Let's say for the sake of argument that it started 6,000 light years away from us. And that
light would just now be coming on. I agree.
Yeah. And now we're looking at the light of a star that's 13.8 billion light years away, even though the light is 6,000 years old. Is that what you're saying?
That is one option. I don't know where they started from. All I know is the Bible 17 times says God.
Okay, hypothetically, it starts 6,000 light years away, and so we see light that's 6,000 light years old instead of 13.8 billion years old, even though the star is 13.8 billion light years away.
No, I disagree, because Adam and Eve could see the stars the first day. So they could not have started 6,000 light years away. Or he wouldn't have seen them. Nobody would have seen them till today. They would just now be flickering on in the universe. And we all know from history, people have always seen the stars. So I disagree. They started 6,000 light years away. But whatever distance they started doesn't matter. The fact is, you can answer the same problem of these great distances to the stars with either great age or a stretching of the universe.
Okay, but the answer is no, and I'm going to get to that in a second. But let's say they're a distance x away. Let's say they're 30 light hours away.
Here's for your theory.
Hello?
You have chosen to believe the stars indicate great age rather than stretching, because you need billions of years for your crocodile to turn into your duck.
So, did a supernatural being stretch out the universe and thus create the redshift we see today? Did this supernatural being try to trick us into thinking that the universe is billions of years of age, when in actual fact it's only 6,000 years old? Has Kent Hovind got any evidence to back up his claims? Well, he has the Bible. As for the scientific evidence for redshift, let us start by looking at what redshift is. How does it prove a continually expanding universe and not one that was stretched out 6,000 years ago by a supernatural being to look like it's billions of years of age? But to do so, let us first look at what light is, as this is important for our understanding of redshift. Light is a form of radiation. For example, too much sunlight can trigger skin cancer. We know that our sun can be harmful to us. Electricity and magnetism are deeply entwined. Hans Christian Ørsted found that an electric current passing through a wire deflects the needle of a magnetic compass. Meanwhile, Michael Faraday discovered that moving a magnet near a wire can generate an electric current in the wire. Mathematicians call this electromagnetism. From this discovery, James Maxwell helped to explain what light is. Maxwell showed that electric and magnetic fields travel in the manner of waves, and that these waves move essentially at the speed of light. This allowed Maxwell to predict that light itself was carried by electromagnetic waves, which means light is a form of electromagnetic radiation. When we view a color spectrum in a rainbow, these colors relate directly to Maxwell's concept of electromagnetic waves. The red light along one edge of the rainbow is electromagnetic radiation with a wavelength of about 620 to 750 nanometers. The violet light along the opposite edge is radiation with a wavelength of 380 to 450 nanometers. A light wave wavelength is generally associated with color. Waves with higher frequencies have shorter wavelengths, and lower frequencies have longer wavelengths. Red has the longest wavelength, and therefore the least amount of energy. The range of wavelengths is called a spectrum, and the spectrum of light contains 7 main colors. So, we know that light travels as waves. The waves travel in straight lines. The speed of light is 186,000 miles per second, and the average distance between the Earth and the Sun is 93 million miles. This means it takes 8 minutes for light from the Sun to reach the Earth. Albert Einstein suggested that light is carried in tiny quantum packets. As already noted, each quantum packs a discrete energy punch that relates to the wavelength. The shorter the wavelength, the denser the energy punch. This would explain why violet light packets with a relatively short wavelength carry more energy than red light packets with a relatively long one. Einstein called these energy packets photons, and they are now recognized as a fundamental particle. Visible light is carried by photons. In other words, light is a particle. This is the famous Victoria Falls in Zambia. Above the falls is a permanent rainbow. Rays of light from the sun are reflected as they enter the water droplets. Light beams then reflect off the backs of the droplets and are bent for a second time. This bending splits the light, and the colours inside are revealed. The colour spectrum we see projected from our sun is the same spectrum when we observe light from other galaxies. As such, we know that a great distance in space will stretch a light wave. When light is stretched, its wavelength increases and it moves to the red end of the spectrum. When we look at the most distant galaxies in the universe, their light appears redder. This means that the space between the galaxy we are observing and our own galaxy has expanded. In fact, our entire universe is expanding. Therefore, its current size now is larger than it was 1 billion years ago. Keep going back in time and the universe gets smaller and smaller until we reach the Big Bang and then to a point of singularity. In the 1990s, astronomers looked at light being emitted from different galaxies. Light from distant galaxies had an increased wavelength compared to light from closer galaxies. This was confirmation and supportive evidence for the work of past scientific endeavours by such legendary figures as Edwin Hubble and George Lemaitre. Edwin Hubble was an American astronomer. It was Hubble who established what is known as Hubble's law, also known as the Hubble-Lemaitre law. This law states that galaxies are moving away from the Earth at speeds proportional to their distance. The further they are, the faster they are moving. The velocity of the galaxies has been determined by their redshift, a shift of the light they emit towards the red end of the spectrum. It is known as the Hubble constant. However, the notion of an expanding universe at a calculable rate was first derived from general relativity equations. Alexander Friedmann was a Russian physicist and mathematician who used the general relativity equations to establish what we know today as the Friedmann equations. They set out the expansion of space in an homogeneous and isotropic manner within the context of general relativity. Friedmann established his equations in 1922. They were derived from Einstein's field equations of gravitation. And then, in 1927, Georges Lemaitre, a Belgian Catholic priest and physicist, predicted the redshift distance relation and demonstrated the expansion speed in his equations. When Hubble confirmed the existence of cosmic expansion and determined a value for it in 1929, it came to be known as the Hubble constant. Due to this work, measurements for the expansion rate of the universe can be used to calculate its approximate age by extrapolating backwards in time. The age of the universe can be determined by measuring the Hubble constant today and extrapolating back in time with the observed value of density parameters. For the sake of some creationists who might be watching this video, I just want to recap on our observations of redshift and why it's a fact. As you can see in this image, and already noted in the rainbow above Victoria Falls, in the light we get from our sun, we get a spectrum. Dark lines in the spectrum contain certain elements. Can you see the dark lines in this image? For example, oxygen molecules might have absorbed into these wavelengths. Hydrogen might have also been absorbed. This means that when the light reaches Earth, certain wavelengths are missing, and the spectrum ends up with a pattern of dark lines. When we look at light from other galaxies, we find black lines in the same positions on the spectrum, but shifted towards the red end, and this is called the red shift. All of the light waves get stretched as they make their way towards Earth across an expanding space. And because space is expanding, galaxies are moving away from one another. The redshift is evidence of this. I want to show you a tried and tested model. This demonstrates what I am saying. The balloon in this image represents the universe. The markers on the balloon represent the galaxies. And you can see the expansion of the balloon represents the expansion of space. It is the expansion of space that is moving the galaxies away from one another. Therefore, as you can see, redshift proves that galaxies spread apart but stay the same size. And as we know, the universe is expanding. We therefore know that we can look back in time to a universe that was once smaller and smaller than it is today, to a point at which we arrive at singularity, a dot of intense heat from which the universe expanded. As we noted at the start of this video, light is described as photons, and photons are massless particles and thus, according to special relativity, travel at the speed of light in a vacuum. They travel at 186,000 miles per second. As the Earth is 93 million miles away from the Sun, it would take light 8 minutes to reach us. The Sun is our nearest star. The next nearest star is 4.3 light years away. For example, if we wanted to travel to Alpha Centauri with our current space technology, then we have a problem. The space shuttle can travel at 5 miles per second. Therefore, it would take us 37,200 years to travel just 1 light year. To make the distance to Alpha Centauri, we would have to travel for 159,960 years at our current capable spacecraft speed to match the distance of 4.3 light years. We simply do not live long enough to make such a journey possible. However, some creationists, and in particular Ken Hovind, do not appear to understand the time factor that is required in the distance of a light year. Here is an example of what I mean.
Time.
Okay, but this is related to time.
A light year is not a year. A light year is a distance.
Okay, Ken, let's try this again. If light has traveled for a light year, it has traveled a distance of a light year. How long has it taken it to travel that?
If it is traveling at 1 light year per second, then it's 1 second old.
Hold on. No, that's not my question. Let's say light has traveled a distance of a light year, yeah? How long does it take to get from the beginning to the finish line of this light year long racetrack?
With no other things affecting it, light would travel about 186,282 feet or miles per second.
And how long would it take?
It would take 1 year to go that distance.
Thank you, Kent.
The speed of light and the length of time it takes for light to travel in vacuum is a constant in physics and does provide evidence for the age of the universe. As for Mr. Hovind, well, only he would attempt to challenge special relativity. Despite his attempts at misinterpreting the speed of light and therefore throwing confusion towards his supporters, I can assure you that in respect of it being used by scientists as a tool for measuring time and distance, it has been consistently confirmed within many experiments. But if you do not wish to take my word, then simply do a little research for yourself. Through special relativity, we can verify the equivalence of mass and energy, i.e., E equals mc squared. Length contraction, moving objects shorten, and time dilation, moving clocks run more slowly. Despite Mr. Hovind's challenges and definition of the speed of light, I am going to take the side of Albert Einstein, and as such, I'm going to accept the evidence that special relativity adds to our understanding of redshift, and not invest any faith in a supernatural being in a book of myths who magically pulled the sky to create the image of an old universe. So, we know that redshift is a fact. We know that the universe is expanding, and we know that redshift confirms this. We can measure the speed of light within our own solar system. Our solar system has a radius of more than 3,500 million miles. That is the distance from our Sun to Pluto. We know that light travels at 186,000 miles per second, which means it takes just over 8 minutes for light to reach us from the Sun. As such, we know that a light year is how long it takes light to travel in 1 year. Therefore, we are talking about immense distances between galaxies. For example, it takes 5.5 hours for light from the Sun to reach Pluto. we can measure light from our next nearest star outside our solar system, which is Alpha Centauri, which takes light 4.3 years to reach us. We know that an expanding universe means that the universe was once a lot smaller. We know that we can use this evidence to extrapolate back in time. As the universe gets smaller and smaller and smaller, we come to a point of singularity. Therefore, we have evidence for a point in time where we had singularity and, as such, evidence for the Big Bang. Another piece of important evidence that supports this video is cosmic background radiation. Discovered in 1965 by American astronomers Robert Wilson and Avino Panzias, it is a faint glow of light that fills the universe, falling on Earth from every direction with nearly uniform intensity. It is the afterglow of the Big Bang. It is electromagnetic radiation. The cosmic microwave background represents the heat left over from the Big Bang and dates back to about 380,000 years after the Big Bang. The heat now is 2.725 degrees above absolute zero. However, it was 273 million degrees above absolute zero, and therefore we can measure the cooling process that helps us to put an age to the universe. And there you have it. This video has been an attempt to explain redshift. As such, it provides another example in my sub-series of videos that looks at the evidence for deep time. Within this video, we have looked at what redshift is and how it helps us to understand the immense distances within our universe and how our universe is continually expanding. And as such, it helps us to extrapolate back in time to the point of the Big Bang. With our understanding of special relativity, what light is and how fast it travels in a vacuum, Friedmann's equations, with Hubble's law, and with our discovery of the cosmic background radiation, we are able to provide an age for our universe which is a lot closer to 13.8 billion years than the 6,000 years proposed by creationists. In my next video, I will be continuing with how we use radiometric dating methods and building on the evidence provided in my video on carbon-14 dating. Until then, thank you for watching. I look forward to your feedback, both negative and positive, and I wish you all good health and best wishes. Goodbye for now.